Let us graph natural log transformed function. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here we have a test example based on logarithmic functions. G of x is equal to ln 1 minus x squared. So natural log, right? The question is, state domain range of g of x and sketch the graph of g of x, right? So range, is all real numbers for natural log, right? So let me write down range first. Range is y belongs to real numbers, correct? We are considering the function g of x, which is equal to ln 1 minus x squared. Now what should be the domain? So let's look into the domain now. For domain, 1 minus x squared should be positive, right? So greater than 0. And that really means that 1 is greater than x squared. And when we square root, we get 1 is greater than, what is square root of x squared? Absolute value of x, right? So what we did here was, on both the sides, we did square root, right? So if I square root both sides, square root of x squared is absolute value of x. Remember that, okay? So we have absolute value of x. In other words, we are saying that absolute value of x is less than 1. So what is the domain of this particular function? So clearly, the domain of this function is that it is within plus or minus 1, right? So now we can write down domain as x belongs to real numbers, so that x is between plus and minus 1, correct? So that becomes the domain of this particular function. Now, when x is between plus and minus 1, do you think range will be all real numbers? So that means rushing into this range is not a good option, correct? You get the idea. Many times I've seen that students will just write range for logarithmic functions as all real numbers. Well, it may not be always true, right? In this function, it is not true. You can yourself see the domain is very much restricted just between plus and minus 1, right? And also, we see that g of x is basically equal to ln, right? So, if you see that, minus x squared, so if I factor out minus, I get what? I get x squared minus 1. Do you see that? That which is reflected on the y-axis also, horizontally reflected, right? And it is only between plus and minus 1, correct? So to sketch the graph, let's look into more details, right? So now let's look into sketch graph. I have still not given the range, right? Remember this, range I'll provide later. Correct? Let us first sketch. Very important, correct? So to sketch the graph, let me take some points, right? So we have g of 0 will be what? It will be ln 1 minus 0, which is equal to ln 1 or equal to 0, right? Now we also know that the value of x is between plus and minus 1. So we have asymptotes, right? We have vertical asymptotes at x equals to minus 1 and x equals to plus 1, correct? You will also notice that this function is even in nature, right? So we also know that g of minus x is equal to g of x, and therefore we have even function. Now with all this, if you see the values of function within plus and minus, so we have come to a conclusion that we do have a vertical asymptote at plus 1 and minus 1. So I am drawing these two vertical asymptotes. We have a point 1 at 0. And as we have increasing values of x, positive values, 1 minus something will be less than 1, right? So we see that the graph actually is kind of like this. So that becomes the graph of this function g of x. And now you can actually write the range. You get the idea. So let me write down the range here for the function. Range is y belongs to real numbers, so that y is less than equal to 0. You see that? It is never greater than 0 in the given circumstances. Since the value of ln within this is 1 or less, right? So that is how the function is going to be. And in that case, all the values will be less than equal to 0. Perfect. So that is how we are going to answer this particular question. I hope the concept is absolutely clear. In case you want to learn from me, you can always send an email on the address given. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.